In the previous lecture, we discussed about the first property of metal, that is metallic luster. Now the next property is hardness, that is metals generally are hard. However, the hardness might vary from one metal to another. One metal might be so hard, some other metal might be quite soft. But as such, metals when compared to non-metals, they are hard. Let's take some examples. Now you will observe there are metals like sodium. They are comparatively soft when compared to the metals like iron, copper, aluminium, magnesium. These metals are hard compared to sodium, which is soft. You can take these metals, hard metals, iron, copper, anyone, and try to cut them with knife. But you will see that you are not able to cut them because the metal is quite hard. But if you try this on sodium, you will be able to cut the piece of sodium, which shows that sodium is comparatively softer than other metals. In general, metals are hard. Whatever physical properties we are going to talk about, that doesn't mean that all the metals are going to have the same property. There are exceptions to it. And that is why substances are not classified as metals and non-metals based on their physical properties, because there are too many exceptions to it. Now the next property is the malleability. Now this is a property by which metals can be beaten into thin sheets. Now what do we mean by thin sheets? Have you ever used aluminium foil for wrapping your food? A thin foil is used for wrapping. What is that thin foil made of? The foil is made up of aluminium. In fact, you would have seen these kind of boxes also. So how do you get such thin sheets out of a hard metal like aluminium? So that shows that aluminium has the property that it can actually be beaten into thin sheets. Now how do you beat it? Let's take a small example. Say take a hammer and take any metal object, say iron nail or a small piece of aluminium, and you start beating it with a hammer. Now when you repeatedly beat it with the hammer, you would see the metal change its shape. So as you beat it, wherever it tends to become deformed in that portion. So basically on beating metals, they are able to change their shapes. So when you vigorously beat it, it might even turn into thin sheets. And that is how it happens in case of aluminium. Not only aluminium foil, another example could be of silver foil, which is used for decorating sweets. If you go to a sweet shop, you will see a lot of sweets have thin silver foil over it. So that silver foil is also obtained from silver metal. So the silver metal is actually beaten into extremely thin sheets, and that is how we get it. And this property is present again exclusively in metals. This property of malleability can be seen into lot of metals like aluminium, silver, iron, zinc, copper, etc. However, gold and silver are the most malleable metal, and it's needless to say, because of this much of flexibility, they are used to design so many jewelry of different shapes and designs. Now comes the next property of metals, that is ductility. Ductility is also a little similar to malleability, but in this case it is the ability of metals to be drawn into thin wires. Now when we talk about malleability, we talk about thin sheets. But when we say wires, we can say the wires for your electricity conduction, the copper wires. So that means it is made up of copper. So copper has been drawn into thin wires. So that property of copper is called ductility. So you would have seen copper wires, aluminium wires. In fact, gold and silver, all of them can be drawn into thin wires. You will be surprised to know that a wire of 2 kilometer length can be drawn from 1 gram of gold. So if you take 1 gram of gold, you can draw it to form a wire of 2 kilometer in length. So just imagine how long it's going to be, and that is why gold is said to be the most ductile metal. So gold has the highest malleability as well as ductility. That is why it's used for designing ornaments. Now, copper wires are used for wiring purposes in terms of carrying electricity. As I said, these metals are also very good conductors. So these are two advantages of using. There are two advantages of using copper wires. One is copper can be drawn into wires. Secondly, copper can conduct electricity. Aluminum wires, they are used for fencing or binding things, so fencing fields or fencing the boundaries. For those purposes, aluminum wires are very commonly used. Now, the next property is the good conductors of heat. That metals are very good conductors of heat. That is, they allow heat to pass through them. Just think of your utensils, you will understand it all. So all the cooking utensils are made up of metals. For example, if you would see aluminum utensils, you would also see utensils made of steel. What is steel? Steel contains mostly iron with a small amount of carbon. Now, what is iron? Iron is nothing but a metal. However, copper is a non-metal, but steel majorly contains iron. So that makes steel suitable for cooking purposes. Now, non-stick utensils, which you can see these days, are very common. Non-stick fry pan, non-stick ball, etc. So these non-stick utensils are also made up of metals. It's just that they have Teflon coating on their top, but otherwise they are also made up of metals. Since they are good conductors of heat, so what are they able to do? When you put your utensil over fire, what happens? The utensil doesn't burn or they doesn't melt because it's able to conduct the heat to the object or to the food item which is placed in the utensil for cooking. So that is how it's allowing the heat to get conducted and it's allowing the heat to reach the food items, and that is how it helps in cooking. So this is another property of metals. Thank you.